larger of two numbers is 2 more than twice the smaller. The difference of the larger number and the smaller number is 9. Okay, so I could think of multiple ways of approaching this problem. Let's first take a straightforward approach using algebra. I'll set up an equation. And now if we're using a mathematical equation, everything in our equation has to be either a number or a mathematical symbol or a variable. So let's look at this problem. The larger of two numbers is 2 more than twice the smaller. All right, so we have this larger number here and this smaller number here. So it looks like there's two unknown numbers here, the larger and the smaller. And it looks like if we start with the smaller number, if we figure out which is the smaller number, then we could do twice the smaller and then add 2 to that, and that'll give us the larger number. Okay, so let's say smaller number. We'll say that we'll give it a symbol, x. Just really all that is a placeholder or a symbol that represents smaller numbers, so I don't have to write the word smaller number every time I want to reference them. All right, so if the smaller number is x, what would be the larger number? Larger number. Now, of course, we don't know what it is, but we know what it is relative to the smaller number. The larger number is 2 more than twice the smaller. We're saying x stands for smaller number. So twice the smaller would be 2x. There's the twice the smaller part. And then we have 2 more than that. So the larger number is 2 more than twice the smaller. So there's twice the smaller, and then 2 more than, we'll add a 2. All right, so the symbol for smaller number is x, and the symbol for larger number is 2x plus 2. And we know that the difference, that means subtraction, the difference of the larger and the smaller is equals 9. So the difference of the larger number and the smaller number, or larger minus smaller, is 9. All right, so larger number is this, 2x plus 2. Smaller number is this, just x. So when we do larger minus smaller, larger is 2x plus 2 minus the smaller number, which is x. That should be 9. Larger minus smaller is 9. All right, so on the left-hand side, we have 2x's here minus 1x here. So those x's will combine to just positive 1x. And there's a plus 2, and we still have this equal 9. Subtract 2 from both sides, and so x is equal to 7. So that's our smaller number. And the larger number, 2x plus 2, larger number, 2 times 7 is 14, plus 2 is 16. All right, and this looks good. If you subtract these two numbers, 16 minus 7, you get 9. And if you take twice the 7 and add 2, you get 16. So this looks good. 7 and 6. Now, another way you could approach this problem, I like this method. It's guaranteed to always work. Another approach we could take is just trial and error. So again, the larger of the two numbers is 2 more than twice the smaller. So that's the larger number. We'll just pick a smaller number at random. Let's say 5. So the large number is 2 more than twice that. So twice that will give us 10. 2 more is 12. That's 12. And larger minus smaller, 12 minus 5 is 7. That doesn't work. We need the difference to be 9. So let's pick something a little bigger. Start with 10. So again, nope, doesn't work. Trial and error. We picked a 5 and a 12. That doesn't work. So if the smaller number is 10, right? Larger number is twice that plus 2, so 22. And if we take the difference, 22 minus 10 is 12. Nope. And so it looks like the 5 was too small. It gave us a difference of 7. The 10 was too big. It gave us a difference of 12. So it looks like the right answer should be somewhere between 5 and 10. And so taking an educated guess, there's only 4 options, 6, 7, 8, or 9. And eventually you would stumble upon the right answer, 7, like we did before. Twice that is 14, plus 2 is 16, and the difference is 9. So that works. So trial and error, also a viable option. Got us the right answer, but it's not always clear how much work it's going to take using trial and error. I like the approach using algebra. All right, hope this helps.